We are here to present the implementation of our project, Development of Non-Invasive Wearable Patient Monitoring System to measure multiple physiological parameters. This project mainly aims the design and development of patient monitoring system which is capable of monitoring multiple vital physiological parameters like blood pressure, blood glucose, pulse rate and oxygen content. In this project, we have developed sensor system for the mentioned vital parameters and prediction of the parameters using machine learning techniques. This is the proposed system architecture of our project. The proposed system, it consists of two sensors. One sensor, TCRT 5000, is used for measuring blood pressure, pulse rate and blood glucose, and DC M03 is used for SpO2 monitoring. The data from the sensor will be sent wirelessly to a smartphone, and from there it will be sent wirelessly to the doctor for further medication and also to a remote server where all the results can be stored. This circuit design is for measuring blood pressure, pulse rate and blood glucose. It includes the sensor data processing where amplification and filtering is performed. Finger is placed on the sensor and the output data is displayed on the oscilloscope. This data is sent to MSP430 microcontroller for further processing. Now you can see the ADC conversion in Code Composer Studio, which is the IDE we have used for coding. The ADC converted data is then sent to a UART terminal. The ADC converted PPG data is taken to MATLAB for further processing to derive blood pressure, pulse rate, blood glucose and SpO2 measurements. A dataset is formed for the prediction which takes the reading invasively for comparison using a clinical device. Blood pressure and pulse rate measurements are obtained using support vector machine algorithms. These are the systolic and diastolic pressures we have obtained with plus or minus 10 mm Hg error and a pulse rate with an error of plus or minus 5 units. Similarly, in case of blood glucose measurement, we are using regression analysis for this purpose. The graph shows a polyfit analysis of postprandial condition from which we can calculate the non-invasive blood glucose level. So here, the non-invasive glucose reading obtained is as displayed with an error of about 1.8 milligram per deciliter. For SpO2 measurement, the same amplification and filtering circuit which was described earlier is used along with the sensor DC-M03. From the output PPG, the AC to DC ratio of both red and infrared is taken, from which the SpO2 data is derived. For SpO2 measurement, we are using support vector machine algorithm. The graph shows the fitting while using SVM and the result is as displayed in the command window with an error of about 1 to 2%.